Hi, this video is going to talk about determining the initial value or the vertical intercept of a linear relation. The learning goals for this video are to be able to calculate the initial value of a linear relation when given information about the linear relationship between two variables, and then also to solve some real-world problems related to the initial value of a linear relation. So what exactly is the initial value or the vertical intercept of a linear relation? Let's just look at an example of a cell phone plan that has an activation fee of $120. So that's kind of what you pay before you even start using the phone. And it costs $20 a month. So graphically, this is the relationship between cost and time in months. You see that it starts at 120, it goes up by 20 every month. This point right here, that's what we call the vertical intercept, or the y-intercept. In this case, it's c, so we'll call it the c-intercept. This is when the graph hits the vertical axis, and that point there is the initial value. So you notice that it's at 120, and the activation fee is 120. Now, in an equation, remember that linear relations can be written in the form y equals mx plus b. Well, b is the initial value. In this case right here, you see the 120 pops up. That is the b value, which corresponds to this point on the graph. Now, from a table of values, again, here's the 120. Now, that's the value when this value here, the t value, is at 0. So you notice, again, that corresponds to this point 0, comma 120, right? 0, comma 120. That's the point right here on the vertical axis. So you can see that you can view the vertical intercept or the initial value in all representations of a linear relation on a graph, as an equation, and in a table of values. So what if we are asked to determine the initial value? So we got to come up with a way to do that. In this case, you see the table here. I don't know what the value of the cost is at 0 months. We got to figure that out because our task is to determine the initial activation fee for Chris's cell phone plan. So this shows the relationship between cost and time in months. So what we're going to need to do is I need to know exactly how much the cell phone plan costs per month. So what we need to do, the first thing is we need to calculate the rate of change. And we can do that by doing rise over run. So we're going to pick any 2 points. I guess I'll just pick the first 2 points right here. Okay. So I've got 2 values there. Remember, to calculate the rate of change, we're going to use rise over run. And that is, we're going to subtract the y value. So I'm going to do 327 take away 255 over, and then I subtract the x values there. So that's 8 minus 5. So that should get me 72 over 3. And then when I divide those two, I should get 24. So this is really 24. Now the rise numbers, remember, that's the cost in dollars. So this is dollars per month. So this is $24 per month. So that's the rate of change. Okay, now that's important because now if I know that it costs $24 a month, let's look at 5 months. I want to know, like, how much does that cost really, because there's going to be an activation fee, something that's going to be added on top to get me the actual cost of $255. Now, one way that we can figure this out in a foolproof method is we're going to do this algebraically by using the equation y equals mx plus b in its general form. Okay. So remember, the y becomes whatever the value or the variable is in the y column. In this case, it's c for cost. So instead of y, I'm going to use c is equal to m. M stands for the rate of change, right? So that's 24. Now instead of x, it's whatever the variable is in the x column. In this case, it's t plus b. Like, I don't know what the initial value is. That's what I'm going after. So what I can do now is I'm going to substitute a value for t and c. Okay, so I'm going to substitute values for t and c. Now I can choose any row here in the table. So let's just pick, I'll pick the first one right here. Okay, so I'm going to substitute this point, 5, comma 255, into this equation, okay, into t and c. So what that's going to look like is the cost is $255, and that's equal to $24 per month, right? Times 5 months plus B. So really what I'm trying to figure out here, let's just multiply this first. So $24 a month, right, for 5 months. That'll get me $120 plus B. So if we take a look at what's happening here, I'm saying that the cost is $255. Now that's equal to 5 months on the plan, right, which is $24 a month, plus some initial value that I don't know yet, okay, like what did he pay at the beginning? So if I just quickly solve this equation, I'm going to take away 120 on both sides. B is going to be equal to 135. So it's for 5 months, it was $24 a month, so it was 120 bucks plus $135 activation fee would get me $255. So using this kind of a method, I can find out what the initial value is. Okay, the initial fee is $135. All right, so we're going to first calculate the rate, okay, how much this was a month, and then using the relationship between time and cost and substituting a point, I can then solve for B algebraically. Okay, we're going to do another example here. We're going to switch up the story. So Brenda has a bank account from which she withdraws the same amount of money monthly. So after 5 months, her bank account has a balance of $1,900. And after 15 months, the balance is $400. The balance is how much money she's got in her account. So we're going to create an equation to model the relationship between Brenda's account balance, B, and N, the number of months. So remember, in order to create any kind of an equation, remember that's going to be in the form y equals mx plus b. So I need to know what the rate of change is, and I need to know what the initial value is. So let's go ahead and calculate the rate of change. So we're going to calculate the rate of change. And remember, that is rise over run. So rise over run. Now this description here gives me two points here. So at 5 months, it's at the balance is $1,900, and then after 15 months, the balance is $400. So I'm going to use those 2 points to calculate the rate of change. So I'm going to do 400 minus 1,900 over 15 minus 5. So that'll get me negative 1,500 over 10, and that's negative $150 dollars per month. All right, so I know that Brenda is taking $150 a month out. I need to know what the balance was at the very beginning at 0 months. So now we're going to use y equals mx plus b. Let's create a partial equation to help us solve for whatever b is. So again, y here in this case, these are numbers, it's the balance. So I'm going to use b for balance is equal to, now m is the rate of change, which we just found, as negative 150. X, so the x numbers here stand for months, so we're going to use n for the number of months, plus little b for the initial value. All right, so now here's remember the new part here is we're going to substitute a point in for n and b. So I can just pick any point here. I'll pick, let's just pick the first one, 5, 1,900, okay, into the value of n and the value of big B. Okay, so let's put 1,900 is equal to negative 150 times 5 plus some initial value b that I don't know yet. So this is saying, okay, how much money was taken out after 5 months? So that would be negative 750 plus b. So now to solve this, I'm just going to add 750 to both sides. I'm going to add 750 to both sides. So b here is going to be $2,650. Okay, so now that I know my rate of change and I know my initial value, the question was asking me to create an equation. So the big B for balance is equal to negative 150n plus 2,650. So that is my ultimate equation relating Brenda's balance in her bank account, and N, the number of months. All right, so let's just go through some success criteria for determining the initial value. So remember, the first thing that we did in those two examples was we determined the rate of change using rise over run. And then we used the form y equals mx plus b. Remember, we substituted the rate of change that we calculated for m. Okay? And then you're going to substitute a point that goes in to x and y there, and then you're going to solve for b, which is the initial value. And then once you're done, you can create an equation relating whatever your x and y variables are, right? Using the rate of change that you've calculated in the first step and the initial value that you calculated in the second step. All right, so you're going to try this question here. We've got a chart that's relating a worker's pay in dollars and time worked in hours. So your job here is to determine an equation to represent the relationship between pay, P, and time worked, T. So remember, take a look at the success criteria, what you need to do in order to calculate the initial value here, because you're going to need the rate of change and the initial value to make an equation. So pause the video, give this question a shot, and then when you're ready, just press play. Good luck. All right, so we're going to pick any 2 points to calculate the rate of change. So I think I'll just pick the first 2 points. So 5, 262.50 and 8, 348. Right? So we're going to calculate rise over run. That's equal to 348 take away 262.50 over 8 minus 5. That'll get me 85.5 divided by 3. And then when we divide, we should get 28.5. So that's dollars per hour. All right, that's the rate of change. Now we need to find out what the initial value is. So remember, we're going to use y equals mx plus b. We're going to make a partial equation. The variable for y right now is p for pay. And that's equal to m, which is the rate of change, times x. In this case, it's t for time, and then plus b, which I don't know yet. Now let's substitute a point. Let's pick the second one. Sure. Let's substitute 8, 348 into t and p. Now remember, it doesn't matter which points you're going to use. You should just end up with the same answer at the end. So let's put 348 for pay is equal to 28.5 times 8 plus b. Now let's multiply 28.5 times 8, and that should be 228 plus b. All right, now we're just going to solve for b, so let's take away 228 on both sides. So b here should equal 120. All right, so now that we know our rate of change and our initial value, we can go ahead and create an equation. So we already have a partial equation here. You see p is equal to 28.5 t plus b. Now that I know what b is, I can finish the job here. So p is equal to 28.5 times t plus 120. Okay. So calculating the rate of change and then using this form y equals mx plus b and substituting a point will get you the initial value. So hopefully you're now able to calculate the initial value when given some data relating the relationship between the x and a y variable. Okay, so thanks very much for watching.